Hi, students. I want to talk to you a little bit about what you might see when you do the Solutions and Solubility Lab. But first, I want to quickly review for you what a solution is. So let me go ahead and write it here at the top. A solution is composed of a solvent, which is the substance that's going to dissolve something else, and a solute. And the solute is the thing that's being dissolved. Now, our first example of what you might see in your lab is a liquid solvent plus a solid solute. So the liquid is doing the dissolving and the solid is being dissolved. Now, in these two examples, what we have is a solute that is soluble. So we're going to take this solid right here and we're going to throw it into this liquid right here. And here is a picture of what it might look like when you're doing that. And once that liquid dissolves that solid, what we'll see is something that looks like this. Now, we can't, with our eyeballs, see where the solid particles are within this liquid substance. So what we have here is we have a homogeneous mixture. And homo right there means the same. So what it looks like is it looks the same throughout. So you can't pick out where one molecule or one ion is for one substance and where the other substance is in there. It just looks all the same to us. So we can also say that we have one single phase here. So I'm giving you all of the vocabulary words that we use when we're talking about solution chemistry. So we have just one single phase there with a constant composition. What we also don't see is something called an interface, and I'll talk a little bit more about that when I get to insoluble substances. But an interface, and that is spelled like this, with F-A-C-E instead of phase like that. They're two different things. An interface, and there's no space like that right there. I don't know why my hand did that, but anyways, it's all one word. An interface is a boundary between one substance and another substance that you can see. And if we go to the next slide, you'll see that right there. So with the sand and water mixture, you can clearly see where the sand ends and the water begins, and that's called your interface. Anyways, coming back here to this example where we have a homogeneous mixture, you do not see an interface there. No boundary between one substance and the other substance. It all looks the same there. Now, what happens if we have a colored solid, like the orange solid down here? Well, what happens is we put that colored solid solute into the solvent, and it takes a little while, because that's what happens, for it to dissolve up into the solvent, but it does. And when it does, what we get right here is another homogeneous mixture. So we can see that we just have one phase there, okay? We don't have two phases like we did over here, where you can see where one substance ends and the other substance begins. We just have this one phase right there, which is our homogeneous mixture or our solution. All right, moving on to what happens if your solute does not dissolve, if it is insoluble. Well, we already mentioned it's going to look something like this right here, and it's going to have an interface. So you're going to have more than one phase, the PHASE that we mentioned back here. So you can see right here we've got the solvent and we've got the solute down there. And this is a sand and water mixture, and you can see where the sand ends and the water begins. And now you've got those two different of matter. And if you take a sample from here and you take a sample from there, you will find that those two samples have completely different physical and chemical characteristics. So, two different phases, an interface. That's what it's going to look like when you have an insoluble solid solute in a liquid solvent. Also, you can have a insoluble solid solute and liquid solvent where your solute is floating on the top instead of sinking down like the sand would do. Or you can have the example over here where you can see the yellow solid solute down there that is insoluble in the clear colorless solvent, but it's light enough to where a few of the solid solute particles are floating up here in the clear colorless solvent, so it makes it look like it's kind of dissolving up there a little bit like we had over here. But the difference is you can see with your eyeballs those little yellow dots, and when I draw them, they're blue dots. But if you take a look, you can see with your eyeballs where the yellow solid ends and the clear colorless solvent begins. So you have more than one phase there. You also have some of that insoluble solute floating on the top up there. So that is definitely something different than you'll probably see in your lab, but it is an example of what might happen if you have an insoluble solute in your liquid solvent. Now, what happens where we have something in between? So we have soluble solid solutes and insoluble solid solutes, and there's always something in between because that's how life is. And that is called a partially soluble solid solute, okay? Or you can just say that your solute is partially soluble. So if we have this example here where we put our orange solid solute into our liquid solvent and we give it a little bit of time, and some of it dissolves up into the solvent, but not a lot of it dissolves up into the solvent because it's only a little bit soluble. What you'll see is if you have a clear colorless solvent, that it'll take on a little bit of the color of that solute at the bottom there. But you can see that we still have the interface there. We still have that boundary that you can see with your eyeballs where one substance ends and the other substance begins. So we still have a heterogeneous mixture here. Whereas when our solute was soluble, what we're going to get is a homogeneous mixture, just one phase, okay? So with a heterogeneous mixture, you can see more than one phase, and you can see where one substance ends and the other one begins. Now, what happens if, say, the orange solute that we have in this example is a little bit more soluble than the orange solid that we had when we went this way? So we're going down this way. So say we go from slightly soluble, so let's call this brand of partially soluble slightly soluble. What happens if our orange solid is a little more partially soluble? So maybe we'll call that moderately soluble. Well, it might look like this right here, where more of it dissolves up into your clear colorless solvent, but you can still see your orange solid down there, and you can still see that interface right there. And more of it dissolves up into that liquid solvent. So you can see that the mixture above is more orangey than what we had up here, but it isn't as orange or dark orange as right here. Okay, so there's a spectrum of solubility. Everything isn't soluble or insoluble and nothing in between. There's a lot of in between. And a lot of times when you're in the lab and you're looking at this stuff, it's just going to be kind of an eyeball thing. If you want to get really technical about it, you can go ahead and read the lab and read how many grams dissolve, how many grams of solute have to dissolve in how many grams of your solvent in order for it to be classified as soluble, insoluble, or somewhere in between, which would be partially soluble. All right, so what happens when we have a liquid solvent, but our solute is also liquid? Well, that's going to bring us to the next slide right here. And I'm going to do the insoluble version first. So with the solid solute, I did the soluble version first. But for the liquids, I'm going to do the insoluble liquids. Now I'm going to erase a couple of lines right there that I drew when I did the first run through of this video, but I didn't like it, so I decided to record it again. So anyways, had to erase those right there. So if you have a liquid solvent and a liquid solute and you want to see if they're soluble in each other, what you would do is stick them in the same test tube or stick them in the same beaker and take a look and see if you have an interface. Now in these two examples right here, we obviously have our interface. You can see where one substance ends and the other substance begins, and that's why I had those lines there. And there might be the question of, well, which liquid is dissolving the other liquid? Well, that's kind of like iffy. They kind of dissolve each other, right? We can also classify the solvent as the one that is present in greater amount and the solute as the liquid that's present in lesser amount. We can do it that way. Or we can just say they dissolve in each other, or we can get fancy about it and we can say that they are miscible or immiscible. Okay, so if your liquids do not dissolve in each other, if they're insoluble in each other, we call that immiscible. If our liquids are soluble in each other, if they dissolve each other, then we call that miscible. So if you have two liquids that are clear and colorless and you mix them together, you're not going to get something that's very exciting. You're going to get a solution that is also clear and colorless. But you can see right here that we have one phase. We don't have an interface. You don't see the boundary between one of those liquids and the other liquid. You just see that one phase right there. And what we see is that there is no color there. So sometimes when you put a couple of things together, they react, but that's not what we're talking about today. We're just talking about two liquids that dissolve in each other, okay? So it'll look like that and not very exciting. Now, what happens if you have a couple of liquids that have colors? Well, it might look something like the example down below. So we've got our orange liquid there and we've got our blue liquid on the right, and they get together and they mix, and what you get is this yellowy greenish solution down there at the bottom. Now, what we would be looking at is after you stopped pouring them together and they mix together, and all you would see is one phase, and all of the liquid in the beaker would look like what I just drew in that square right there. It would be that single color, just a single phase, no interface, okay? And we would say those are miscible liquids, whereas these are immiscible liquids. All right, so what happens when you have somewhere in between? Well, that is possible too. And we have a couple of things that are partially miscible down here. And I'm going to do the bottom example first because that one is a little bit easier to see. So what we have here is bromine. Now, bromine is one of our liquid elements. Bromine, when it occurs in nature, actually comes in twos. So that would be Br2. But anyways, it's bromine liquid. And then if we put it with another liquid with water, what we're going to get is something called bromine water. And if you go on in chemistry, what you'll find is bromine water is used in specific reactions. If you go on all the way to organic chemistry, you'll see bromine water again. And you'll learn about what kind of reactions it does. All right, so anyways, we have bromine and we have water. These are two liquids, and we put them together. And what you can see is that we have the dark substance here and a clear colorless substance here. And up here, we have the clear colorless substance that has some of the dark substance dissolved in it. That's what we can see with our eyeballs. What we probably can't see with our eyeballs is the fact that the clear colorless substance also dissolves down into the darker substance. But anyways, that's what that's going to look like. All right, so what happens when we have a couple of clear colorless substances or liquids that we put together that are partially miscible? Well, we're going to go ahead and put them in the beaker together. And just in case you can't see it, what I've drawn is kind of a yellowy swirly thing in that solution right there. And if I draw it in blue, what it looks like is that. And it doesn't look as good when it's in blue. So hold on, let me see if I can expand this a little bit. So you see how I've drawn a little yellow swirly right there? That's kind of what it looks like when you have a couple of clear colorless liquids and you put them together and they're only partially miscible. When you shake the test tube, like when you swirl it around or you swirl the beaker around, it looks kind of swirly or oily in there. Whereas when you have, oh no, now it won't go back. Oh, there we go. Yay, okay. Whereas when you have a couple of liquids that are completely miscible, what you'll see is that clear colorless solution that probably just looks like some water. You don't see anything funky in there. Whereas with the partially miscible liquids, you'll see something that looks unusual in there. And again, to me, with my eyes, it kind of looks kind of weird, swirly, and oily. So that brings us to the end of this presentation. So there's your blank slide. Woohoo, we're done. So hopefully that helps you with determining if your mixtures are heterogeneous or homogeneous in your lab and giving me a solubility conclusion. Is it soluble, insoluble, or partially soluble? And if you want to get fancy with your liquids, you can also do miscible, immiscible, and partially miscible. All right, until next time, bye-bye.